Okay, so just coming in, get your make sure you have get your internet out with your laptop or your smartphone or your iPad. And then I guess there's an app for smartphone that will make it a little more seamless, a little easier if you want to download the app eventually. Okay. All right. So again, student sign in. So from tophat.com, you're going to go to this green button, student sign up. Find Arizona in the list. You're going to find Arizona State University by starting to type out Arizona State University, and it'll get that from the list. Go next, and then put your name in. So Jerry Student. Your email, for your username, please use your ASU Right ID, your ASU, the one that you log into My ASU with. Then just use something else. Well, let's figure out what that is. Okay? And then choose a password. Agree with the terms and conditions. Look at that. Oh, maybe like at another university. So this you're choosing from all usernames of everyone on Top Hat. That's why. Okay. Agree with the terms and conditions. Valid email. I hope that's not real. Probably is. Oh well. Okay, you can set the grading setup. You can say skip, I will add later. We'll just use the default. Adding a phone is optional. It would be in case you didn't have your internet with you and you wanted to text your answers in. So you could add a mobile phone, or you could do it later. And then you get to this page, and down at the bottom of the list, you want the third from the last. 171, make sure you get 171, 130, and enroll. And this is where we want to be. Okay, I can't do a lot of troubleshooting, but anyone think they have a quick question that I might be able to answer quickly? How many people are here where I'm on the screen? Raise your hand, nice and tall. More than half. The rest of you are getting there, you're on your way? You're close? Question? Yeah, okay, if you need the 6-digit code, the 6-digit code is 364234. So if you can't find the course and you do a search on the course, no, that's wrong. That's the other class, sorry. 425115. Our class is 425115. But if you found it in the list, you don't need that. Okay? If you found it in the list, you don't need that. All right, we're gonna start. We're gonna do a couple questions. Okay? So you should be at this screen right here. Oh, really? So the following are quantities. How about meters? Is meters a quantity? No, that's a unit, right? That's not a measurable attribute. Okay, what about a race car? Object, no. Width. Yes, that's something we measure for some object, right? That's something we measure for some object. Okay, 500, is that a quantity? Okay, so before we started this course, you might have thought 500 was a quantity, right? Because you associate quantities as numbers. That's not how we defined it, right? We define a quantity as a measurable attribute, so 500 is not. What about 17.6 seconds? Same thing, nope. Acceleration. That's a measurable characteristic about an object, how fast it's accelerating. Okay, the 18,000 fans. Is that a quantity? No, that's really saying the fans, right? That's really talking about the fans. It just happens to use a number to describe them. So this is not, the fans is an object. So it's not, the fans themselves are not a quantity. We could say the number of fans. If we said the number of fans, now we got a quantity. Okay, so remember that a quantity is a measurable attribute of an object. Okay, so even though width and acceleration are quantities, they're still deficient here. How is it kind of a deficient? What's missing? Yeah, so more description, right? Width of what? So a specific description. So make sure your quantities are well defined. For instance, the width of the race car over its front axle. Is that well defined now? Yep. And then acceleration. Acceleration of the race car during the last lap. Okay. Acceleration of the race car during the last lap. Okay. Do we need to put units on these? Yes. As quantities. As quantities, no. As quantities, it's just the characteristic. It's the width. It's how far it is from here to here. Okay? Acceleration. So again, it's a measurable attribute, but we don't have to measure it. We just describe what that characteristic or attribute is. When is it when we need units? When we define a variable. So now if we say W is the width of the race car, well now W is taking on values, right? We say a variable is a letter that takes on all the values that the quantity could be. So now when that variable takes on values, then we need a unit, because if we say, 8, well, 8 what? 8 inches, 8 miles, 8 feet, 8 meters. Okay, so when we define variables, then we have to have units. So it feels like we had some mostly success using Top Hat. Okay, so we'll always be ready to use it in class. Sometimes at the beginning, sometimes in the middle, maybe sometimes at the end of class. Any quick questions on Top Hat? All right, let's talk about the syllabus. Okay, I'm gonna go quick. We got lots to do. So you guys here you are. Email is the best way to get a hold of me. There's my email address. My office is in ECA 209. That's right across from the bookstore. Right across the street from the bookstore is ECA. My hours are 11:30 to 1, Tuesdays and Thursdays, and also by appointment. Okay? We should have the workbook by now. The workbook looks like this. It's 4th edition. You need that workbook. Bring it to class every day. Also, you'll need a graphing calculator. If you've never used or have very little use with the graphing calculator that you have, they've got workshops that are basic getting started for graphing calculator. If you know your way around a graphing calculator and you've maybe had a whole course where you used it, graphing and using different things, this probably won't be for you. Okay, you probably already got most of that content. But if you just bought it or you had little use, I recommend the calculator workshops next week, Tuesday and Wednesday at 6 p.m. Yeah.
Where can we buy this?
Any bookstore online, you can find them used. Yeah. So yeah, there a new one, a TI-83, that's the most common. A new one is something like 80 or 90 bucks. Used, you probably find 50, something like that. All right, essential websites. These are the 4 websites that we'll be using throughout the course. Blackboard, of course, is our home base. Rational reasoning is where the online text is, and we're going to just delay that a little bit because there's lots. I don't want to overwhelm you. Web work you've already found. You had your assignment due this morning. Top Hat we just took care of today. In terms of attendance, there is no excused and unexcused absences. Okay, so you don't have, if you miss class and you think it's an excused absence, don't spend time writing me an email and having me read it, or because basically you just have a cushion of 4 absences in this course for this lecture. Okay, so and then you have a cushion of 2 absences for recitation. Okay, and while we're talking about recitation, Megan is here joining us. She's back from the dead. So it's right after this class, right? So some of you have a recitation right after on Tuesday and some right after Thursday. And so the Thursday recitation you will be going today. Okay? Megan's certified pre-calculus genius. Okay? So she is here, she's on your side, all right? She's here to help you and help you get through the course. All right, and that leads us to tutoring. In terms of tutoring, your best help that you can get is Megan and myself, okay? We're the very best help you can get. A very close second to that is this pre-calculus help room. And actually, that's where her office hours will be, in this help room, okay? We're doing our best to train these tutors in this help room in this curriculum. As you find out very quickly, this curriculum is different than a traditional math class. And as such, other help that you might find on campus might not be very good because they're not familiar with the way we're approaching things and the things that we're holding as important. Okay, so we're still finalizing the location and hours of this, and as soon as that gets up and running, I'll be reminding you about that often. Okay, so again, best way to get help is myself and Megan. Then the next best place is going to be this help room, and in the past it's been open something 30 or 40 hours a week. Okay, so this is your best resource. If you go anywhere else, it's going to be a distant third in terms of the help they'll be able to give you because of the nature of this curriculum. It's different. Question?
If I'm signed up for the Tuesday recitation after this class, would it be acceptable to go to the Thursday recitation after this class?
If once in a while with special permission, but you should go to your own. You should go to your own. What's that? Oh, yes, absolutely. If that's okay with Megan. Yeah, if you want to go to both for extra help, that's great. You're welcome to do that. So yeah, and it might, because it's Tuesday and Thursday, what happens in recitation on Tuesday may be slightly different than Thursday, and so you might have something different or just reinforcing the ideas. That's fine. Okay, so I will let you know when where this will be and when it will be open. They're working on that. Pretest. If you haven't taken the pretest after this class, you've got to get in there by 6:30 in PSA 21. If you haven't taken this pretest yet. Okay, if you don't take this pretest, you won't get your score for exam 1. Okay, so it's required for everybody, and if you don't get in there, 0 on exam 1, which digs a deep hole for yourself in this course. Okay, so do it. The whole process should take less than an hour. Bring a Sun card, but you don't bring a calculator. You don't have to study, and just do your best. Okay, and I'll give you, based on your performance, I'll give you some extra credit on exam 1. Okay, so yeah, if you haven't taken it yet, you've got recitation, or some of you do, so you've got then a short window to get in there. So you got to get in the door. You don't have to be done by 6:30. You can just be in the door by 6:30. It's open until 8. Okay, you can work until 8. Okay, exam 1 is coming up quick, like 3 weeks. Okay, so if I seem a little bit rushed in class, well, we got it. I want to make sure we get through the material for the exam, but we'll do our best to go slow enough so that you can get it. Okay? Then we'll have the other 2 exams we'll talk about, a post-test and a final. Breakdown. 3 exams are worth 40%. Final will be worth 20. Homework, 25%. And then the top hat, 15%. The rest of the syllabus is general stuff that you're responsible for, but we won't go over. Some important dates for this semester, and then the very important academic integrity statement. Okay? So you're responsible for all that. Any questions on the syllabus? Okay. I just want to visit Blackboard and show you around Blackboard a little bit more here. I've started some new things. So here's in the home page is where there'll be announcements. Okay, syllabus, you should have already found it. And also in that syllabus section, there's a student startup guide for the top hat. Probably you won't need it. You'll learn all that stuff on the fly, but just in case, you can check that out. So I've opened a new area here called assignments. Okay, you're going to be going here a lot. Every Tuesday and Thursday, I'll be posting an assignment. So here is Tuesday's assignment. There are 4 potential things every class that could be happening. Well, not quite sure, but there's 4 in every assignment. There's 4 potential things. Web work, and you have one due on Tuesday. Okay, that's already open for you to work on. Written homework will be due on Tuesdays. Okay, that's in your workbook. Starting on page 55, do these problems. I gave you a note here changing the wording on number 30. Okay, online readings. So none at this time, but in the future we'll have some online readings. And then during many of the recitations, maybe not every single one, you'll have a short quiz where you're writing out. Okay, so next week you will have a quiz number 1, and here it is. I posted it. There's the quiz. So you can get 100 as long as you prepare. Okay, as long as you prepare. So there's the quiz, and that you'll have that either next Tuesday or next Thursday. So this is your task. These are your tasks for Tuesday, and that is in the assignments area on Blackboard. Okay, class videos. So by 5 or so, 4:30, 5 p.m. Is that true? Yeah, 5 p.m. or so, I should have that day's video up. So here's the video from Tuesday. Especially the fact that this is a Tuesday, Thursday class. We're covering a lot of material in every class because we only have two sessions a week. And so I think these videos are going to be especially important for you to consolidate your learning, reinforce what we went over in class, because there's going to be so much in every lecture that we do, and you've got so many other things going on in your life, right? So you may walk out of class and you may think, oh yeah, that makes sense for the most part, like I totally got it, I understand. Well, a couple hours later, you're doing something else, you're at other class, you start to forget, and then 12 hours later, it may be mostly gone. Okay, so that's what the point of the videos is. You learn by repetition. You learn by repetition, and so you need to reinforce, consolidate the learning that you have in class, and the videos are helpful for that. So take advantage of those. Course websites we know about. Office hours. Once the Tutor Center gets going, Megan will have, we'll get the office hours for Megan up there. These are wrong. I have to switch this. 11:30 to 1. Tuesday, Thursday is mine. Okay, 11:30 to 1. Okay, questions about Blackboard? Okay, so talked about the graphic calculator workshop, Blackboard, Top Hat. Okay, we're good. So let's practice a little bit more with quantities and variables. So I have a video I want to show you. I'll watch this a few times. So, and as you're watching it, I'll let you know what you're going to be doing with a partner is you're going to be brainstorming, trying to think up distance quantities in this situation and time quantities in this situation. Both constant and changing quantities. So there's lots going on here. You got a man, you got a woman, you got a bridge, okay? So again, you're going to be thinking of distance quantities, both constant and changing, and time quantities, both constant and changing. And the key is to really be specific and not vague, and so we know exactly what quantities we're trying to identify. Okay, so I'll just keep running it. So why don't you get a partner? And you're trying to write down. Here we go. I'll show you. Okay, so distance quantities. 3 constant and 3 changing, and then the changing ones we're going to actually define as variables, okay? And then time quantities. 3 constant and 3 changing, and then the three changing time variables we're going to actually define variables for the changing ones. Okay, so is the task clear? 3 of each, constant, changing, distance, and time quantities. So you're trying to come up with 12 total. And our key is being very specific as to what quantity you're defining. That's the key. Watch out for being vague. Think about someone else reading it. They need to know exactly what you mean. Here we go.
Left. left. Left, left.
Okay, let's see how you did. So, anyone volunteer? A constant distance quantity that's well defined in this situation. Yes, sir. What's your name?
The length of the bridge.
The length of the bridge. Can I say the distance from start to end of bridge? How about that? Is that what you meant?
Yeah.
Do we need a unit? If we're just defining the quantity, we don't need a unit. It's just how far that is, that distance. Okay, that's just that the quality of that bridge, right? The quantity bridge. Okay, someone else. Does someone else have another one over here? Yeah. Okay, so you're kind of thinking outside of the video. There's just a portion of the race, so that's okay. Total distance of the race they're in. What else? Yeah.
Distance from the beginning of the video till she started running on the bridge.
Okay, so the woman's distance, woman's distance
Start of the video till she
ran from start of the video
till she's to the beginning of the bridge.
to the beginning of the bridge. Is that a constant quantity? Is that a constant quantity from where she was at the start of the video to the distance she ran to the start of the bridge? Yeah, well defined? Yeah, good. This is good. Those are all good. All right, how about changing? Somebody new. Yes, sir, in the back.
We said the distance between the two runners.
Distance, let's do a variable. So can you define it as a variable?
The distance between two variables, the distance between two runners in feet.
Yep, and what variable you want to choose?
I guess just D.
Yeah, sure. D equals distance between the runners. And you said in what?
In feet.
How do you do? Is that a well-defined variable? Specific enough, and it's a quantity that has units. Who else? Yes, sir.
The time they took to finish the race.
All right, so we're still on distance. We're still on distance quantities. This is where we're changing distance quantity. So we can do time. We'll do time later. Yeah.
The distance covered since leaving the tunnel.
Okay. So, and what do you want to call that? What variable?
C.
C equals distance
Covered since leaving the tunnel.
covered since leaving tunnel in feet. Okay. So is it a quantity? Is it specific enough? Maybe. What's what?
Doesn't add the guy.
Yeah. So we got to pick which runner we're talking about because that's exactly because the woman's covering a different distance than the man is. So the distance covered by the man. How about that now? Is that a good changing quantity with units? Yeah, because so C could take on all these numbers of feet. So at one point he's 1 foot away. C equals 1, and then he's 5 feet away from the exit of the bridge. And then C equals 5, and then C equals 13. He's 13 feet, right? So it's taking on all those different values. Okay, anyone dying to give me another one of these? Yes, ma'am.
Distance covered since the woman started running in meters.
And what variable do you want? Any? A. A equals distance ran by the woman since when? Since she started running. In what? In meters. How'd she do? It's great. So, yep, so at some point she started running, and then A is now how far she's ran in meters, and that's a changing quantity. She ran 2 meters, then she ran 8 meters, then she's run 15 meters, then 100 meters. And so A takes on all those values. That's a changing quantity. Okay, how about time quantities? Somebody new, constant. Who has a constant time quantity related to this video? Yes, sir?
The time from when the man said left to when she actually turned left.
Excellent. Time from when man said left to when she turned left. Is that a fixed amount of time? A constant quantity? Definitely. Good. So there's another hand. Oh, it's back here. Yeah.
Oh, the time it took the runners to cross the bridge. From the start to finish.
From the start of the bridge to the end of the bridge. Okay. Time it took. I'll say traverse, make it easy. What do you think about that? Is that a constant quantity? You hear what he said? So what? How can you clarify? How can you improve this? Good. Excellent. Yeah, because they each took a different amount of time to get through. But if you just say the woman, now we've got a fixed amount of time. Okay, changing. Who's got a good changing time variable? And we'll make it a variable. So how about over in this corner over here? Tell me your name right here. Awesome.
The time from when the race began to the race finished, starting to the point they're at now.
Okay, is that a changing quantity?
No, I honestly don't have.
Okay, that's all right. So how are we going to get a changing quantity? Somebody new. Yes, sir.
Say T equals
T equals?
the time elapsed since they, or since the man left the bridge.
Is it a quantity? Is it specific enough? Does it have units? Well done. All right, so this can take on 1 second, 3 seconds since he left the bridge, 10 seconds since he left the bridge. So T takes on all those values. One more. Who's dying to share their? Yes, sir.
At the time we took to finish the race.
Okay, and is that a changing time quantity to finish the race? So when I run a race and I go back afterwards and look on the internet, my race time, is that changing or constant? That's constant, right? That's constant. So is there another changing time quantity we can do? Sure, go ahead.
The time elapsed since the woman started running.
And so pick a variable for that. W, perfect. She wants the time elapsed since the woman started running. In seconds. Is it a changing quantity, first of all? Is it specific enough? Does it have units? Okay, so why are we emphasizing this so much? Throughout the whole semester, you're going to come to situations with quantities, and you're going to define variables, okay? You're going to define variables, and you want to be specific and define them with this amount of rigor, because you're going to be working with expressions and doing calculations and coming to some final answers. These are your reference points for what those final answers mean. If you start with something vague or you don't define anything at all and you do some calculations, you get a number, are you going to know and be able to know for sure what that number represents and means? Lower probability if you haven't really defined well what your variables mean. That's why we're taking the time to do that. And that's going to be a big value for us in this course, is as we're working through problems, what do expressions mean? What do numbers mean in the situation? So we're going to be asking that question a lot. Okay? And so this is really important. Questions about quantities or variables? Okay, so here is a quantity. Z equals the amount of rainfall in Tempe since August 1 in centimeters. So here I am trying to define a variable. Was I successful? according to our criteria? Z equals the amount of rainfall in Tempe since August 1st in centimeters.
Yes, yes.
Lots of yeses. Yes, right? It's a quantity that's specific and has units. Okay, so here's a little kind of like a number line. Okay, so this red bar here is a representation of the variables or the quantity that we're calling Z. Okay, so that red bar is a representation of the quantity that we're calling Z. How is it a representation? So what is this red bar showing about the quantity Z? Hopefully this is an easy question. Yes, sir.
Since August 1st, it's rained 8 centimeters.
Okay, and so the bar is 8 centimeters long on this timeline, and so he's saying that right now the current value of Z is 8. The current value of Z is 8. Yeah, exactly. Okay, and so now I can change that. So now, what does that represent? What does that represent right now, what I'm showing you?
That the value of Z is 3.
The value of Z is 3. And so therefore there's been 3 centimeters of rain in Tempe since August 1st. Okay, very good. So now what about this? Put that there. Let's make this one bigger. And let's do this. Oh, come on. So I'm not introducing any new quantities here, okay? It's still about Z, the amount of rainfall. But I put this blue bar up here. So what might the blue bar represent relative to Z? Any ideas?
Possible quality of the rain between whatever centimeters to whatever centimeters it is.
So the amount of centimeters from starting from this number to this number. Okay? And so what could that represent then, that blue bar? What about quantity Z would that bar be representing? Okay, yeah, that's true, but I don't want to bring time into it at all. I just want to keep focusing on the amount of rain. So, what's that? Anybody going to offer something up? Okay, so what is this? This is about, what is this value right here? Z equals what? Well, 1.6. And what does this look like right there? 5.6. So that blue bar represents a change in the amount of rain, starting at 1.6 and ending at 5.6 centimeters. So at some point after August, the amount of rain hit 1.6, and at some later point it hit 5.6, and so that blue bar is showing that change. How much was that change in rainfall? Okay, and so this is the symbol, delta means the change in. Okay, so the change in Z, in this case, the way I'm showing it is what? What is the change in Z? 4 centimeters. So delta represents a change in a quantity. Okay? Specifically here, I'm showing that change in the quantity starting when Z was 1.6. Okay? So tell the person next to you, what does the blue bar represent now? Go. What does the blue bar represent now? Let me do something else. Sorry. Sorry, I'm trying to get it to be in the right spot. That's fine. Okay. How about that? Okay, so right there. So now what does the blue bar represent now? Okay, somebody new. How about in the corner there, in the light blue shirt? What do you think? What does the blue bar represent now? Not sure. How about you next to him? What's your name? Mohammed? What's the blue bar represent? Are you guys listening or looking at your computers?
No, I'm listening, but I'm not sure.
Okay.
Change in Z, or change in the variable Z.
Okay.
2.2 to 6.4.
Good. So we're starting with z equal to 2.2, and z ends at 6.2. And so the whole thing represents a change in z. And how much is the change in z? So is this the same or different than last time? It's the same amount of change, but starting at a different z value, right? So we can have the same change starting anywhere that we want. Okay, so how about this? One more situation. If I can grab onto these buttons. Okay. Maybe. Right there. Okay, now explain the whole situation to the person next to you. What is this whole situation showing? Go. What is this whole thing showing? Okay, Alec, what do you think? So the whole picture, can you describe the whole picture? What is it saying about Z? Okay. Okay, so we said Z equals 1.5 and then a change of Z from 1.5 to 3.5. What do you think about that? You right? Okay, so then who can tell me the same story talking about the rain? So same thing, interpret in terms of the rain. What is this telling us about the rain? Yes, sir?
The amount of rain that has fallen up to 1.5 centimeters.
Okay.
The blue bar would be the prediction of the rain expected to fall.
Could be a prediction. Okay. It's going to fall. Yeah, so we took a reading and Z was 1.5 centimeters. And that was since August 1st. And then what happened? It rained. It rained. And how much rain did we get? So that right there, I've already done that. Doing that. Okay, that's what the bar is for. All right, so then this is an additional amount of rain starting at 1.5 of 2 centimeters. So we were at 1.5 and we had some sunny days, and then we had a rain, and it rained 2 centimeters. More, right? And so then after that rain, where's the red bar now? What's the value of Z? 3.5. So after that happened, now our value of Z would be 3.5, and if we wanted, we could extend the red bar now out to 3.5. Okay, so now I'm going to tell you that this change in the amount of rain starts at 2.79 centimeters and ends at 5.13 centimeters. What's the change in the amount of rainfall? What is delta Z? Find delta Z. What's the change in the amount of rainfall? So it took you a second, huh? What'd you say? What is it? 1.20, 1.43. 2.34? This is what I'm hearing. Agree? Three, 4. How do you find it? So you can't do this, in our head, or maybe some can, but how do we find the change in a quantity? Are we right? Is this right? 2.34? And how do we calculate that? What'd you do?
Subtract the endpoint to the start.
The final value of the quantity, we could say z final, and then initial. This is how we find the change in a quantity. You take the final value of that quantity and subtract the initial amount. Should make sense. So what did I tell you on Tuesday? That this course is all about quantities. And then we could take that a step further. We could say this course is all about changing quantities. Okay? And so we need representation. We need symbols to talk about the change in a quantity, right? So that's what this delta z is. It's a way of representing the change in a quantity. Any questions? Okay, and then we could take that take that description one step further, and we could say that this course is about how two quantities change together. Different ways that two quantities change together. So let's do an example here. Perfect. Okay, so we're going to whip up an amazing chicken recipe. So we need to go to the store and buy some chicken. Okay, so here I've defined a couple variables. I'm saying X is my total weight of the chicken that I'm going to buy in pounds, and Y then is the resulting cost of the chicken in dollars. How did I do defining those X and Y? Did I take care of everything that we talked about for defining variables? Sure thing. And so at this particular store, so chicken is $3 a pound. So if I bought 1 pound of chicken, how much is, so if when X is 1, what's the value of Y? 3. And when I do that, I've got this graph down here, I get a point. So on this horizontal axis is representing which quantity, X or Y? X, the total weight of the chicken. And we got 1 pound. And then this axis here, the vertical axis, is the cost of the chicken. So when you look at that point, what does it mean? What does that represent, that point? He said 1 pound of chicken costs $3. Exactly right. See, this is what's ingenious about graphs, is when you have one point that represents two things, two values simultaneously. The value of X, and it's simultaneous with the corresponding value of Y. Okay? So that point represents the value of two quantities taken together. In this case, that point specifically is 1 pound of chicken, and it's a corresponding cost of $3. Okay, so what about 7? What's going to be the cost of 7? 21. Ah, shoot. Sorry. Just 1 point now. Just 1 point. Okay. All right, so now it automatically moved our first point here to 1, 3. And now again, we have another point that represents 7 is the weight, and the corresponding cost, 21. How much does 3 cost? How much does 12 cost? Am I almost done plotting all the possibilities? Am I almost done? How many possibilities are there for amount of weight that I could?
Infinite chicken.
Yeah, there's lots and lots of, I mean, I haven't even gone into, say, 1.5 pounds, right? Or 7.2 pounds. So there's lots and lots of possibilities. So here I've got a bunch of those. Sorry. Okay, so can you see all the points? You're supposed to be able to see them. Okay, there we go. That's better. Okay, so there's all these points. But if I zoom way out, what do you see? Even further than that. Sorry. That's better. Okay, so that's the same, all the same points that I just plotted. What do you see? A line, okay? So graphs. You're all familiar with graphs, right? Graphs. This particular graph is a line. So when you look at a graph, what does a graph consist of? It consists of these many, many, many points. Each point is the values of two quantities taken together. In this case, weight and cost of the chicken that we're buying. So I made that too big. Darn it. There we go. Okay. So usually so now, instead of plotting all those points, it's easier just to draw a line like this. So you see graphs like this all the time. Newspapers, magazines, textbooks, your future engineers are going to be working with graphs all the time. Okay? So on this black line right here that I've graphed, how many points are there? 5 points on that black line. Is that right? More than 5. 7. That's right. So, and what I'm getting at here is when you see either a curve or a line or a graph, it's just the quick way of representing what? Many, many, many points. And so when you look at a graph, you have to have that image of it because that's what it is. Okay? It's not a wire that we could bend and move around. Okay? It's a representation. It's the quickest and easiest way to represent many, many, many points. So there's not 5 points there. There's like an infinite number of points there. These are just highlighting 5 different points on the line. Okay? But there's many more. So right here there's a point. Right here there's a point. Right here there's a point. Right? So anywhere we go on that line is a point representing a value of pounds of chicken and the corresponding cost in dollars. Okay, so let's talk about changes. So we were talking about changes in the quantities, and so I want to say that x is going to change from 1 to 3. What does it mean in our situation? If x changes from 1 to 3, what is that about? What does that mean? Starting at? So we had 1 pound of chicken on the scale, and we said, oh wait, that's not going to be enough for me. And then so I told the butcher to put 2 more on. It's a change in x. That's a change in x from 1 to 3. Of how much? 2 pounds. And when x changes from 1 to 3, y does only one thing. It changes from what to what? It must change from 3 to 9. And what's the change in y then? Delta y, 6. So we want to show that on the graph. This change of x from 1 to 3, can anyone describe how we can represent that, show that on the graph? What's that?
If you did change the graph from 1 to 3, so that would be the gradient of the graph.
Okay, so I'm going to add something to this graph. What should I include along with this graph to show x changing from 1 to 3?
It's like the blue line that you just did before.
Okay.
But just add it from 1 to 3 for the for this line.
Horizontal axis or vertical?
For that, no, for the grid.
But I only want to show x changing from 1 to 3.
X changing from 1 to 3.
Uh-huh. From? Yeah. So it's like that the bar that I showed you previously, right? So we can draw a bar like this, 1 to 3, and that will show the change from 1 to 3. I could also put that starting at our point, right? So that's what I'm going to do. I'm going to start here at the point and go from 1 to 3. And right there, that will be delta x equal to what? 2. Representing what? Is that representing an increase in pounds or cost? Putting 2 more pounds of chicken on the scale. And when we do that, what's the result? That the change, yes, $6 increase. You see? When we do that, there's a $6 increase. So this little kind of triangle thing is showing a change in x, and then the simultaneous change in y. So you got this change at x of 2, and then y will go up 6 simultaneously. Again, we're starting to explore this idea of how quantities change together. So what I want you to do is just using values from the table that we have over here on the left, I want you to create some new lines in this table over here. Okay, so everyone will have different answers, but create some new lines in this table over here using the values that I gave you in this table over here, and then we'll draw them. Okay, go. Okay, Morgan, did you get one of these? Did you make up one? Tell me, what did you decide? X goes from what to what?
1 to 7.
1 to 7. Perfectly legitimate. And so, what was your change in x when x changed from 1 to 7? 6. And as x changed from 1 to 7, how does y change? 3 to 21. And that's a change of how much cost? How'd she do? When x goes from 1 to 7, y changes from 3 to 21, which is a delta x of 6 and a delta y of 18. He likes it. All right, so I'm going to do that in red. So where am I going to start? I'm going to start that same point and go how far? Right there. And so the red bar I drew is now delta x of, how much did x increase? 6. And as we made that increase of 6 pounds, we paid $18 more. And we can show that with that vertical line going from what? 3, here's 3 to 21. So we started at $3 when we had 1, and then we bought 6 more pounds, we went up to $21. And so we can show that over here as delta y. Okay, let's do one more. Did anyone start at, just for the sake of the drawing, anyone start at 7? Anyone do one from 7? Yeah, what'd you do? 7 to 12. Then y changes from? And what was your change in weight? And then change in cost. And I'll do that in blue. So I'm going to start at 7, x equals 7, and we're going to add on how much How many pounds of chicken? And how much will our cost go up? Anybody have a question? Okay, so I'm going to do this. I'm going to start there. Go back to black. And I'm going to do a change of x from 12 to, what's this one? Yeah, 12 to 3. Can I do that? Does it make sense in the real world? Does it make sense in the real world?
Put it back where I want it.
Yeah, so how much was on the scale?
There's 12.
12 pounds. And what do we do? Removed how many pounds? 9. And so what is delta x? -9. If we take final minus initial, right? We said that the change in the quantity is the final value of the quantity minus the initial. 3 minus 12 is -9. And we like that because now it distinguishes. How does it distinguish between how the quantity is changing? These quantities before, how are they changing? Increasing. And so if we have a negative change, that's the quantity's decreasing. We like that. That's nice. That's nice for us to just have that mathematical way of saying, hey, this is an increasing quantity versus a decreasing quantity. All right? And y changes from what to what? Which is a change of? So delta y equals? -27. All right, I'll draw that here. So we start at that point at 12. And we're going to do x first. Okay? So we're going to do x first. So I'm not going to go down first. I'm going to do x first, which is like that. I'm going this way now because it's a decrease. Delta x is -9. And as delta x was -9, as that happened, our costs went down. We just saved how much money? $27. Delta y is -27. We're going to pay $27 less if we take 9 pounds off the scale. Okay, so notice something here. How can we calculate, looking at all these relationships? Delta x is 2, delta y is 6. Delta x is 6, delta y is 18. Delta x is 5, delta y is 15, etc. What does delta x, delta y, how can we always calculate delta y? How can we always calculate delta y? In the blue shirt, right here. What's your name?
Justin.
Justin. So how can I always calculate delta y? We're showing it over and over again here.
By initial minus the.
Okay, right. So the final value of y minus the initial value of y. But how can we use delta x to calculate delta y? How about behind him there? How can we use delta x to calculate delta? What's your name again?
Jacob.
Jacob. How can I use delta x to calculate delta y?
If we have a formula for like y equals 3x, then you can always find y if you know x by plugging it into the formula.
But I want to know what delta y is given delta x.
Oh, delta y. It's usually, isn't it always a multiple of delta x?
Right. And I'm asking you, what exactly is that?
It's 3 times x.
What were you going to say, Christian?
I was going to say 3 times the change in x.
3 times the change in x, isn't it? No matter what delta x we picked, the resulting delta y was always 3 times that. And what does delta x mean again? What does it mean?
Change in pounds.
Increase or decrease change in pounds. And the delta y is?
Change in cost.
This makes sense. Chicken is $3 a pound, right? So if we make any change in the weight, our change in cost is going to be 3 times that. Because every pound is $3. Okay?
What if the opposite?
What's that?
Like you want to find, you have x and you want to find y,
Mhm.
so we divide it by 3.
Yeah, so delta x is always delta y divided by 3. Yeah, true. Okay? All right, so this right here, if this is always true for a given relationship, if always true, then we have what's called constant rate of change. Okay, the days of y equals mx plus b are over. We're going to learn something much more significant. Why? Because it's a dynamic, right? It's about how the quantities change together. It's not just here's a line and here's its name. It's about quantities changing together. So constant rate of change. So it's a very specific way that two quantities can change together. If you have this, so what is this saying? It's saying that the change in one quantity is always a constant multiple of the change in the other. The change in one quantity is a constant multiple of the change in the other. Okay? And that's talking about proportionality. Okay? That's talking about proportionality. When you did proportion problems back in junior high and maybe early high school or whenever you did them, okay? Proportion problems. What was that? What were those problems about? What did you do? You did ratios, right? And we said this ratio equals this ratio equals this ratio, therefore we have proportionality. So we're talking about a constant ratio. What ratio would be constant in this situation? The ratio of what to what would be constant? What's that? So the ratio of what to what? In looking at these right here. So 3 is equal to what? What's always equal to 3? Looking at all these different situations here. Right here in the dark blue sweatshirt. Yeah, no, you, yeah. Yeah, in the back row, yeah. What's always equal to 3? What ratio is always equal to 3?
Just a bit slow. I just think that you understood it.
Oh, it doesn't mean you can't listen in class. Tell me, what's ratio is always equal to 3 in these situations here? 15 and 5, 18 and 6, 6 and 2, negative 9 and negative 27. Okay, we want 3, so it would be delta y over delta x. Okay, again, so we have a constant, what we call a constant ratio. Of the changes, constant ratio of the changes. Okay, so what was this? What was summarized at the end? Well, again, the change in one quantity, delta y, is a constant multiple of the change in the other. We also have the fact that this ratio of delta y to delta x is a constant. Okay, and then there's one more way to look at this. What if I increase by 4? Okay, so here I am at 1. I'm going to increase from 1. Delta x is 4. What's delta y? What is it? 12. Okay, but now starting at 7 pounds, I'm going to increase by 4. Still an increase in 12. And then starting at 12 pounds, I'm going to increase by 4. Still going to go up by 12. Okay, so what we're saying here is, if you have equal changes in one quantity, what will that result in? A consistent change in the other. So I have a summary of all this. So we'll summarize in a second here. So consistent changes in the one quantity always gives a consistent change in the other. So this is our summary of constant rate of change. Here we go. This is the last question on your quiz next week too. Two quantities vary together at constant rate if equal changes in one result in consistent changes of the other. Every time we add 4 pounds of chicken on the scale, we pay how many more dollars? 12. Doesn't matter where we add the 4. we always pay $12 more. Okay? The change in one quantity is a constant multiple of the change in other. And we found out that the increase in price, delta y, was always what? 3 times the change in x. And the last one was that the changes, corresponding changes, maintain a constant ratio. Delta y over delta x always what? Always 3. Same constant value. Okay, remember this on Blackboard, you've got the assignments tab, and that gives you the full checklist of what you have to do for next week, including the quiz next week. Okay, you got web work, you got written homework, and you got that quiz to prepare for. Have a good weekend.